Welcome to our science seminar this week. I want to remind you, maybe you guys have heard that the Mathematica people, Wolf from Alpha, are going to be here tomorrow afternoon, Friday afternoon, from, I think, from 2 to 3 in, I believe it's Keith Hardwick 104. Is that correct? Yes. So if you're interested in Mathematica and interested in ways to do your calculus homework with less effort, okay, probably behoove you to come out and hear what Mathematica has to tell you about things like this. So 2 o'clock tomorrow, which is Friday, in Keith Hardwick 104. You got that down? Oh, yeah. All right, put that on the BuzzNet? Oh, yeah. All right, put that on the BuzzNet. All right, today we have with us Gary Hanson. Okay, he is a hydrologist and a former Navy Marine and geologist.
Marine geologist.
Yeah.
Acoustics specialist. Yeah.
He's done lots of different things. And right now he's the director of the Red River Management Site that's part of the Louisiana State University system over there by Newport. And he's going to be talking to us today about the Red River, flooding, droughts, and all those other important things that you might be concerned with at the Red River. And I want to remind you that after we're done here today, we'll be going to lunch over at the Corner Cafe. And if you want to join us for a conversation with Gary there, we'll be in that Joyce room. So feel free to join us there at that time. But let's give a nice warm welcome.
Thank you very much. A little business out of the way. A lot of my family are buried over here in East Texas. I hate to put it that way. Not too many alive over here. Any Phillips in here? Anybody know any Phillips? Come to me after class. I'd like to talk to you. I'm trying to track down some relatives. Our Hansons, but particularly Phillips. I had a couple uncles that grew up in Smackover, Arkansas, where I grew up. I was born in Shreveport. My family, during the Texas oil boom, moved to Texas and were here. Lost a lot of them here over the time, and a lot of my relatives. So I am a local person. But I grew up in a little town, Smackover. It's known in the oil and gas industry throughout the world. And it's one of those things that we're actually having a family reunion coming up. It's a town that got a whole population of 2,000. But Gladewater, Troop, Texas, there's some other localities in the area here. Over at LSU Shreveport, we do have an engineering program, petroleum engineering program, jointly with LSU Baton Rouge. We're all one now, which is making it a little interesting, since I have to approve everybody's salaries and everything to Baton Rouge on the computer. But my background, I actually usually keep it with me just so I can remember where I'm at or who I am. I have to put this up, so this gives a little bit. You don't have to read all that stuff. It just kind of reminds me who I am and what I'm doing. BS at Louisiana Tech, Master's at University of New Hampshire in a brand new program, which now is probably, I think, the top in the world in the area that they're doing in marine sciences, mapping the Arctic Ocean and whatever. There were 7 of us that started the program, and the other people became famous, important people, not me, but them. The park that we have is a very unique facility at Shreveport. It's on the Red River. It's the only instrumented oxbow lake system down inside a levee, I think, anywhere in the world. I worked directly with Bill Mitch at Ohio State University until he recently left, and that was the premier site in the world for studying wetlands. And we went to Washington together right after 9/11. That's how I got a lot of funding from our facility over here. They were having anthrax scares, so we had to work with, everybody had PowerPoint presentations, and I had one map of this facility, and that's all they got to see, all of our senators and representatives. And I guess it helped because we had LSU Baton Rouge there, and we had Ohio State University, and we ended up with the funding, fortunately. That's what I do. Remember every single one of those little circles that you do. I love this little program, by the way. That's the way I think. I'm a visual spatial thinker. I am a geologist. I'm realizing I'm in a room with a lot of engineers, and I'm okay with it. I've worked with engineers my whole life, mostly with engineers. The Red River is, a lot of people don't realize where the Red River starts and where it ends, in particular where it ends, especially those in Congress. Definitely don't know where it ends. It doesn't end in the Mississippi River, by the way. But it actually starts, I hate to tell you this, I know you're all good Texans. It actually starts, I've tracked it, faked my family out on a vacation to go out west to find the headwaters of the Red River, and I did, on a little farm, a little creek. So it actually does start in New Mexico. And I'm gonna go through these slides, some of these slides kind of fast, so don't worry about taking notes. You have a copy here. This was the actual way that it looked back when Captain Shreve, that was his actual name, which Shreveport was named for, he developed the flat bottom riverboat and snag boat. He came and started clearing out rivers in the United States, mostly known for the Mississippi River and the Red River. The Red River used to flow into a meander, which is a bend in the river of the Mississippi River, Turnbull Bend, very famous bend. A lot of your parents' money went to this structure over the years. If you read McPhee, and any of not any, but he's got a lot of books out that tie into geology. He's got a whole book that deals with this structure here that we're talking about. It's very important because the Mississippi River doesn't want to stay where it's going. It wants to go through Lafayette, Louisiana. And I've worked that whole coast for the Oil Spill Coordinator's Office, mapping that area, a whole other topic we can't get in today. But anyway, he took Turnbull Bend, he wanted to cut it off to shorten the route for trade back in that time frame. There was also a famous, let's change that, infamous, very secret, Thomas Jefferson, President Thomas Jefferson had more than that big expedition that went out to the West Coast. He had one that he kept pretty doggone quiet called the Freeman and Custis. And a few years back we held a meeting in Shreveport and had scholars from all over the world to come talk about this. But this is part of that presentation. I gave a tour down the river and we involved this. But the Red River comes in from the north here. This is well down in southern Louisiana. I'll show you from an engineering perspective, since we have so many engineering interests here, where your billions of dollars have been spent, although it will be ultimately, from a geologist's perspective, ultimately wasted, because I think the river will eventually take over and go where it's going to go. And it's not going to be New Orleans anymore. So get down there where you can. This is the Cheflau River. Well, it was blocked up right then at those times. Just like most of the Red River was from Alexandria up through Shreveport into Arkansas. Was blocked up by trees that came out of Texas, north of here. Just to kind of give a comparison, 1806 to present day, these are some of the important things we need to look at from a hydrology perspective. Our watersheds are all natural systems. We've had free-flowing tributaries. You can see on the right what's been done by modifications. And then the main channel, flood channel, the most famous geologist, I guess, of all time, Darwin's buddy who pushed him to write his theory, Lyell, came here to see this great flood. I don't know of another analogy anywhere in the world. We know it lasted at least 800 years. It's mostly red cypress that came out of Texas and clogged up such a massive area. And also why that area of the country stayed non-developed. The Caddo Indians were able to maintain their residence there for a long time until they were shipped off to Bingham, Oklahoma. And then Texas, as it was beginning to form, they made an agreement with the Caddo Indians so that they could also move into Texas, which they immediately, I'm sorry to say, broke totally. So they went to Bingham. I have talked with them on numerous occasions. Well, the red goes across this massive area to the west of us. As we start to gain elevation in West Texas, there's Amarillo. We have the Llano Estacado, the Staked Plain. It was a famous area for the Spanish people that had come to the North America, and they had to actually put stakes in that plain to follow it. It's so clear, so treeless for mile after mile after mile. They call it the Staked Plain, and it went to Santa Fe, New Mexico. So that's where it starts. Mostly starts out up at this area right here. Satellite image not the greatest, but you can see a big canyon here, Paladero Canyon, right here. It drops about 1,000 feet at that point. It's the biggest drop on the Red River. And then it becomes the border, which has recently been finally decided between Oklahoma and Texas. and still a whole big deal about water going on. That's another whole topic we could get into another day. But notice these little things here. These are actually, what do you think those are, these dots? I'm looking at these dark areas. What do you think they are? Dots here, there. What could they be?
Lakes.
Someone said it.
Lakes?
Well, I wish they were, but you only have one natural lake in the state of Texas. And you know what that one is, right? Caddo Lake. That's the only natural lake you have. Those are all reservoirs. Those are engineered structures. Or you wouldn't have water in Texas, pretty much without those. In the last few years, in the drought to 2011, most of those went down to 2%, 5%, 10%, and it's going to happen again, unfortunately. Have been working on my PhD at the University of Arkansas in environmental dynamics, ABD there, studying into the future how we can change things and what we need to do that. This is what it looks like. It's about a 1,000-foot drop. It was famous for the Comanches running the buffalo off of these cliffs and then living for the whole year. One trip over that cliff would do it. But they also had this red Permian age. That's about 500 million years ago, geologically speaking. Red clays, which makes up the Red River. We got a little different if you go to Cyport and Shreveport. I can help develop that. Please, to get an opportunity, please go over there. It's a wonderful facility. Anybody been to Cyport? Great. Good deal. We go all the way even past Dallas. A friend of mine sent this. It lives right there, actually down at one of the forks of the Red River that goes through the canyon. Another view here showing our official compact reaches. We're in Reach 5 in Arkansas. I had to get up and stand up in Texarkana a few years ago and be the bad guy. I was asked by the headwater guy in Louisiana to stand up and say, the water that's going past Dallas and into Louisiana is not wasted in going out to sea. We actually do use that water. And please don't put those signs on the buses anymore saying that that water belongs to Dallas, Texas, because we do use that water. And the guy right behind me stood up and said, I'm the guy that put those signs on those buses. And I apologize. We shouldn't have done it. We understand you need that water. It was an interesting thing. I've run into a lot of these different beaches. But we have a compact between the states that you're seeing right here. And there are restrictions all up and along, except pretty much down in Reach 5, which is in Louisiana. Now, what we're looking at here is those that may be ecologically oriented. We go across 7 different ecoregions. Here's your source, Armoric, 1987. Pretty rare for a river system anywhere in the world. We go across 7 ecosystems to the time we get from the headwaters up in New Mexico, which is quite rare. And you can see where I'm at today is we're still in the same ecoregion right here. Now here's some statistics, and I know you're going to love that, being engineers, some of you. But you can see real quickly where the population is located. Denison, Shreveport would be back here. Texarkana would be there. What should that be? Could be Denison, could be, yeah. It's really growing up in that area tremendously. So you can see we're along that Red River, but we are the largest right now, the largest between Shreveport and Bossier municipality on the Red River. Great place to put a watershed management institute. I hope we're able to establish these on every major river system. We're going to need them. You're going to need them wherever you go. Again, another map that's I can move on through pretty quickly just shows you all of the different engineered structures that have been put in this watershed, as the EPA likes to call it. It's also called a river basin. A lot of different structures up there, owned by different agencies, as you can see. But a lot of water gets trapped behind those, and sediment trapped behind those too. For years, since 1951, they've been lowering the salinity of the Red River. So by the time it gets to Shreveport, it literally is getting close to being able to do what Bossier City uses as a water source. They do treat it. But it's not far from now that they won't even have to treat it that much at all. We have an aquifer that goes right below the river, the Red River Alluvial Aquifer, which I've been able to help the oil and gas companies get into for the hydraulic fracturing, which is not used now for consumption or very little used. We've gone through the first ever dealing with water and hydraulic fracturing took place in Shreveport, Bossier, and a lot of it through our institute. working with the oil and gas companies, the local, the state level, and it sent me to China, Australia, Alaska, a lot of nice trips because of it, which I learned a lot in, by the way, and been able to share. But as we move on down, there's that view again. You can now see these features a little larger, the lakes. Caddo is right up here, well, excuse me, right here. It's Caddo Lake. And then that's what you have for water. And if you have dry cycles, you don't have water. You went down to, I think, 3% at the major lake, just north of Fort Worth. I forgot the name of that lake. Pardon me?
Lake Louisville?
That one was real low too. Yeah, all of them went down just super low back in 2011. I was asked by actually to give a talk at the climate. We have a joint Oklahoma, Texas, Louisiana consortium on climate. And I was asked to come as a non-member of the National Weather Service to give a talk about, because we've been monitoring groundwater on a monthly basis prior to, during, and after that event. That's the only data set available. And we monitor it not like the USGS on quarterly basis for level, but monthly basis. And you're going to see it turned out to be very helpful for us in determining our water resources over in Louisiana. Every quarter, we take samples and do water quality studies. And just to give you an idea of all those different water bodies that have been built, a lot of engineering work has been done in Oklahoma and Texas here, and particularly. This is a little dated, but it shows what I need to show. 1995 is when the Locking Down 5, the most further north of the $3 billion project, to put in basically navigation on the Red River. I will tell you this, not very many people know this, a lot of people will be upset to know it. We have had one barge travel the Red River in the last 2 years, mainly because of our flood problems and damage done to the situation. But it's mainly recreation is what it's been used for mostly, to be honest with you, so far. We hope it will continue to grow. But notice the level jumped up here and it stayed up here. It jumped up 18 feet at Shreveport from its normal average level and stays at a pool stage now that's rarely lower than that pool stage of 147 feet above sea level. So it's still pretty low when you think of 2,000, 3,000 feet in the upper reaches near Amarillo and the Palo Duro Canyon. To give you an idea, a very basic structure here, if you haven't had any geology, our systems are very, very dynamic in a big floodplain. They're moving continuously back and forth, meandering back and forth, leaving levees, leaving oxbow lakes, which we have at our campus and are able to capture into our university system with a joint agreement with the city of Shreveport. But a lot of aquifers come from here for your water from these point bars. The Wilcox Formation, which is huge in Texas, been drawn down drastically in your region, unfortunately. That's why you had such a tough time in Tyler and some of the other cities. And you also go on a different system for management of water. You're put in at the west. So it's whoever comes first has ownership. And just so happened during that drought, Tyler had 3 lakes or reservoirs that went down to practically zero. And then the senior rights holder on the coast of Texas said, I want our water. And they could not let the levels in those reservoirs. Even if it rained, they had to let the water go through those reservoirs out. And the groundwater's practically depleted in the Wilcox Aquifer, unfortunately. We haven't depleted that in Louisiana yet, mainly because we've been using predominantly surface water. But anyway, this is our park, our summer park here. It has a little E shape to it, a little unusual shape. But now we have levees, almost all river systems, and certainly the Red River does, through much of its course. Now has, so we don't supposedly have flooding. I went through a 5-hour meeting yesterday that went all the way, I think, up to Obama's office. We had representatives dealing with the 3 major floods we've had in this 1 year. The spring, I drove up through here in the spring of 2015 was the main stem flood. Then we had a backwater flood in the winter, which is horrendous. And then we had you heard about what happened at Baton Rouge. My daughter lives down there. She moved to one of the areas that I said never build any houses. Those houses were flooded to the roofs. It was 100% loss. So that's what's got the administration heavily involved. And we had at least 5 major agencies in that meeting yesterday, and very, very difficult meeting to coordinate. I stepped away from having those meetings. I started them originally and I shifted it to someone else, and I was so glad yesterday. The river has 5 locks and dams. I've been up every single one of them. I went into the river in Monroe, Louisiana, went down to Washita River, which turns into the Black, then goes into the Red right down here. And I've gone up that river. I've gone down the river from there, out into the Mississippi, through the one place you can get out to the Mississippi. And then I've gone down the whole of Chapalaya by boat, all the way across Intercoastal Canal and up the Vermilion, right up to the Hilton in Lafayette. And parked our boat and went into the hotel there. This is just a picture of one of the locks and dams. These locks cannot take pressure. I shouldn't say it that way. Where the actual lock and dam part, the lock part of it, cannot take pressure. You cannot not let water flow out that area. That doesn't help us when we have high water coming down the Red River. We can flow water through this and at the bottom let some sediment through it. And that's what you're seeing right there is sand on the downstream side. A lot of the river, this is a major high point. The Native Americans were smart. They picked up areas where you would have a little small stream coming into the major river. We call that a Yazoo stream, because the lowest point in the floodplain is actually near the upland areas. The highest point is right along the bank because you have a natural levee forming continuously. I wish I could encourage some engineers, particularly in Shreveport, to let it stay there when it floods instead of scooping up, moving away, and instead of spending tens of thousands of dollars modeling equipment and stuff down on the riverfront where they could just let nature take its course, but that's not happening. This is Natchitoches, and this is really neat because we have the Cane River. You may have seen steel magnolias. I know it's centuries ago, but the Cane River is where it takes place. That was the river when the Spanish came up and started developing the river. It broke away in what we call an avulsion, and for about 60 miles it runs as a separate small stream now. The Red runs just to east of it. That's what it looks like on a topographic map. This is a really high bluff right here, and this is where Bayou Pierre that starts in the city of Shreveport as an Azure stream. Gets all the way down to here. There's a nice facility by the Corps of Engineers right here where you can also see a really nice fossil that I got cast many years ago of an ancient whale. The skull is about this big. And we have one at Cyport in Shreveport too. We kind of beat them to the punch, so they had to put it down here in Natchitoches. This is a river after they straightened it. Look at all the rivers parts have been cut off. That's efficient for flow, for getting things up and down. It's maybe not the best way for rivers to operate. Rivers operate more efficiently when they can do their meandering like this. These are fisheries that are cut off in many cases. The ones that are left open have really been a tremendous help. This is, you can see a Cane River goes down the side. I may have left that slide off. A little geochemistry I did working on the work at Arkansas. This is 42 centimeters in the adjacent lake south of the city is 1963, precisely, because that was the peak. It's been switched to 1964 this year. That's the peak of above-ground atomic testing. Cesium-137 can be picked up in some reservoirs. We're fortunate to have it in our lake and was able to get many, many samples of that. Also did lead dating. We know that about a centimeter a year goes into that lake on the south side of Shreveport. Here's our lake adjacent to our campus right here. It's a couple hundred acres here of the Oxbow Lake, altogether about a square mile. Involved in this facility. This is a view during about a 50-year flood a few years back. That's one reason we got the lake. It floods. The city kept putting playground equipment and replacing it every year because it rusts. Because it's flooded half the year. Not half the year, but for months. Lately it's been over half a year. In fact, it's still closed right now. That's great for us from the science standpoint, but the whole idea was to put a research and education park, education and research park in a public park where the public could see what we're doing and come ask questions and learn. Believe me, the public needs to know more science and engineering and technology. Really deficit. This is something we don't know who did it, but this is Sunflower Point is where our facility is located. These are the courses of the Red River over a number of years, starting back in 1886, all the way up to the 30s or 40s, I think, 38. 49 was when this was cut. Some stories about some dynamite was involved, but anyway, that's what happened, how we ended up ending with that Oxbow Lake. Notice we kept these levels with the city. This is what happened when the locking down 1995 was closed. Notice the average porosity here of your flows. You could walk across the river many times a year in Shreveport when it's dry. You can't anymore. It's held at this constant level up here or higher. Notice the peaks we're starting to have, and we had our worst one here in the spring of 2015. The same flow that flew out of Toledo Bend, that went out of Toledo Bend, 203 thousand cubic feet per second, flowing past Shreveport, was what they were able to put out of Toledo Bend, which sank Interstate 10. You may have heard about it. Shut down Interstate 10, all traffic between Texas and Louisiana. But they were under orders to do that, and I worked very closely with them. Okay, here's our research park. We drill wells in it. I worked many years with the oil and gas industry. We drill one deep well all the way down to the Midway, which is right above the oil and gas zones. This is the lowest formation that outcrops in Louisiana. Most of our water comes, like I said, in Texas and East Texas, and our area has been the Wilcox Formation. In the river, it's, of course, eroded down. A lot of water's in there, a lot of resources there. Not being necessarily used today. Some of the casinos are using them, I can say that. But this is a tool we only have used in oil and gas. It's been very effective. I've run about 100 of them in my consulting work. We cored the whole hole. We were able to find a fault in it, a break and slippage. We found a cold seam, and we found one little aquifer in there. And when you see this little line there, that tells you you've got ability for fluid to flow through, permeability. So that permeability is the this is the Red River alluvium aquifer. Right below goes down to 66 feet. Then we go immediately into 50 million year old sediments. And that's the Wilcox aquifer. It's a poor aquifer in many areas. 50 gallons per minute, unfortunately. Then we had about 1.5 feet of it right here. But this also gives you grain size. It's a wonderful tool. It's just like when you go in the hospital and get an MRI, except it's done to the outside, out into the formation. And you can tell the difference when you have oil and gas in there. It's a direct indicator tool, as we call it. Like I said, I run about 100 of those. Halliburton came in, and we got this all done for $20,000 and 12,000. I had to get a crane. They came from Texas. They came from Mississippi, Oklahoma. They all wanted to come help and be involved in this well. There's no other well like it in the world. This monitoring well has got just about every tool that they use for oil and gas exploration run on it. That's the well that we keep monitoring, large diameter well. Here's the Cane River. To give you an idea, there's the water source right there for Natchitoches, right here. And this is what the Spaniards found and settled at, right in this area here. Unfortunately, the river decided to do what we call an avulsion. It broke through its natural levee and went this way. As I mentioned before, the upland area right beside it is the lowest area. That's why you have the tributaries, these Yazoo streams available. And just north of here is our Yazoo stream that starts in Shreveport, Bayou Pierre. These are the 5 locking dams. I've shown you those before just to give you an idea of the different reaches. Boy, did we go over those yesterday with FEMA and the Corps, USGS, every agency you can imagine. Here's a close-up look at the Red River, where remember the Ouachita turns into the black, right here. I've gone down that by boat. Interesting trip. Also the Curtis and Freeman, they mentioned the first geological, the first expedition with a scientist on board. The one that went to the West Coast, you've heard of those guys, right? Okay. Well, Freeman and Custis is one that's kept quiet by Jefferson because it's on the Spanish border. And it was actually stopped just as it got into Texas, where they met resistance, and they turned around and went back south. It was an expeditionary, it had a lot of meaning to it. They wanted some science collected. They wanted to know what we had out here, but they wanted to know what the Spanish were doing at that time. There was more than just the Alamo, to tell you the truth, in the history of Texas. But you can see this very clearly. This is where it comes together. It used to come in right in here, in this old meander here. It's been cut off, and it's been so messed up. There's so many different structures put in there they keep adding more and more water now that 33% of the Mississippi River flow has to go into the Red Atchafalaya and out where we're forming new sediment in South Louisiana. It's the only place we're forming new ground. Everywhere else is sinking. Or the Mississippi River will break through, and you won't have New Orleans anymore. It's that simple. And we just keep pouring money at it. Like I said, Maffei wrote a whole book about it. There's the up close, just to give you an idea of the details of the engineering structures. One of them is a power station that was built into it. A lot of things are boondoggles, unfortunately, that we deal with, but there is some electricity generated there, but they just keep putting more ways to get water into the Chapalaya. And I've taken an instrument down the Chapalaya. It is deep, and it may be the deepest river in the United States, and it is very turbulent, as they say. A lot of people claim it's the deepest and most turbulent river in the United States. Okay, let's talk about in the winter of 2016. This is what we call our backwater flood. In the winter, we had this incredible flood. Most of our floods come from Texas, come from up north, melting snow, almost to New Mexico, on the main stem of the river. I've had to educate a lot of people, mainly politicians. We've got another meeting coming up, all the new ones going for office, where we're going to educate them again. They're trying to. It doesn't work well. It doesn't stick. I don't know what the deal is. You know, does anybody watch Brain Dead? By the way, how about Halt and Catch Fire? Anybody watch that? Computer nerds. Halt and Catch Fire. Anybody? You haven't seen that series? Oh, you gotta watch that series. They just brought in the ARPANET. That's what I used when I was in the Navy on the West Coast. We were tied in at the universities. That's how we collected data, and I could look into Russia sonically. That was the beginning of the internet. Go check it, ARPANET. It's not published too much. That was the internet. That's how it began as a military experiment. And it worked very well for transmitting data. That's what the floods look like, the rainfall across. This is a levee right across here. This is outside the levee that's protected. This is the Red River. What do you think this is right here? Houses, $1.7 million houses built inside the levee that flooded. Those houses are now at a value of about 10% of that 1.7 million. They actually let them build inside the levee. And that's not the only development. This is some of the things that are coming out now that I've been trying to stop for years. This is the backwater flood. Mostly it was not real high-end houses like it was in South Louisiana. Poor houses came that close, literally that close to taking 20,000, 30,000 high-end houses in Bossier City. I spent 2 solid days watching hydrographs, talking with the administrators, trying to help them plug the holes in the dike like a little Dutch boy. And luckily we had a lot of convicts. That sounds terrible. Barksdale Air Force Base gets a lot of credit for their people volunteering, but mainly it's a lot of convicts. We wouldn't have been able to save Bossier City. So water and aquifers are becoming huge problems all over the United States, all over the world. I've taught this for decades now. It's moving on decades. And it's not getting any better. Everything that we predicted has come to fruition. I don't talk about climate change. It's not a real popular topic in this area of the world, as you can imagine. But an old grizzled geologist told me this. I was fortunate to be one of 16 members of the first hydraulic fracturing workshop that was set up in Baltimore. The top scientists from our national labs, top geologists from oil companies, EPA and whatever, we all got together and worked this subject and dealt with it. And he said to me, don't ever talk climate change. Just say, look, we're going to have a higher frequency, more intense storms. And it's exactly what is happening to us. In fact, it's a crisis now in the country, as the president has seen. I'm glad this president has been able to see this. I hope the next, whoever gets elected, will do something with this. We put in 10 wells to monitor. I mentioned before, that's where they are. Our students put the wells in. In my class, they did the mapping, the subsurface mapping. We went out, we had a drilling company come, but they went out with us. They put the wells together. We have a contract with the parish. My students that work for me go out and monitor these monthly for half-life. We had one well that was looking strange, which is, we see it on the internet quite a bit lately. Right here, it was kind of going down during the wrong time and up during the wrong time. That's the way it should have been. Here's the well that was going in the wrong direction. We started watching this very carefully on our monthly observation. This is when I got together with the oil and gas companies, the state, the parish, everybody together and says, we got a problem here. We can't be pumping this much water out of the ground for fracking. in this immediate area of a large populace. And this is the first place, anytime that the industry has come in voluntarily and gotten off of groundwater and gone to surface water. And it's become a model, I've been told, it's being used worldwide. We pulled these groups together starting back in 2003. I'm not going to go through all the people involved, but we obviously had a lot of people involved with this. I won't go through the details of how I do my adaptive management approaches. I've got a simple little program I like to use that helps me map out things. I'm a visual spatial person, and that's the way I plan and work things out. But we work closely with the state, but there was no surface water law. Nobody knew that. So we had to work out a way to get water from the river, and we were able to do that. This is kind of a long-term of that well that I was showing you. When I started to see the crisis, we got the people together as a group, got them off the groundwater. This is what happened the next summer. Notice it should be lower in the summer. More people drawing water in the summer, less in the winter. So go up and down. If you take it monthly, you see this. USGS doing it quarterly, and this is this type of frequency. So it's a high resolution. And notice it's continued to go up, and even beyond this, it's continued to go up during this El Nino event that we've had, which has been very, very large, the largest to date. And it's strangely not going into La Nina like we thought it was. It's very, very unusual weather. We have not and cannot predict it. We have the National Weather Service that works with us. Here's the water levels. We had, right before the drought, this is what happened. 1 month, 21 inches, bam. Then we went into the drought, 2011. Well, you got hit bad in Texas, very bad in Texas. We started the first emergency order and still is in place. I pulled them off at the beginning of the El Nino, my prediction of the El Nino, which turned out to be about 3 months before I was called to that National Weather Service meeting, and the top climate modeler says we will go into an El Nino 70 to 80% in the next 2 to 3 months. So I said, give the people a break, except industry. I want to stay off the groundwater. This is what we tend to happen. We went from all groundwater to almost all surface water, 77%, by getting together and working with industry. It can be done, and this is what you need to do into the future, and be thinking about whatever your career is. Work together with people. That's the most important thing you can learn to do, is interpersonal skills. I actually was an interpersonal skills teacher at Pennsylvania when I was there. There's the drought up close and personal. Toledo Bend, as you know, went almost totally dry during that time frame. This is where I finally got the governor to listen to me and everybody, and we started to get everybody off the groundwater and just show you how low the water did get at one point. This is the closest USGS well we had. We had 0 in Caddo Parish. We had 1 in DeSoto, just to the edge of the area. And notice they were in there longer than us. And it had been declining for years and years, and then it just dropped off the chart when we went into that drought. This is where I said I'd kind of speed up a little bit. So the drought started there. It wasn't the oil and gas companies that caused this, by the way. It was the drought that was the biggest single problem. It was a bad time for them to start drawing water around a municipality. That was for sure. It's been going up ever since due to the El Nino effect. If you draw it onto the surface, a lot of surface water, they draw less water out of the ground. It's just that simple. You're not recharging that water that fast. We don't know how long it takes to recharge the Wilcox. It could be 500, could be 1,000 years. Not in our lifetime, I can say that. Well, let's go to oil and gas for a little bit. This is what our mature fuels have looked like since 1980, and what had been predicted up to about 2015 or so. Hydraulic fracturing, I started it, I really date myself, 1976 here in East Texas, Carthage Field. That's where the biggest fracking ever was, and still is in a lot of ways, history-wise, for the tight sands. That's before we got to the shales. And we started fracking there what we thought were big jobs. We weren't doing horizontal drilling. This is what we're looking at around the United States, our resources. The Hanson in East Texas and North Louisiana is one of the largest gas reservoirs in the world. The wells are deeper, and it has the highest pressure of any, to my knowledge, any shale reservoir. It has no liquids. It has no oil and gas with it. That's the unfortunate thing, and why a lot of companies left and went down to the south, to another area. I've spoken down there on water issues to them, to the south. We have Marcellus in the east. I've been up to there, which is massive and huge, but they don't like you to frack there. I have been having to deal with those issues too. This is what it looks like. Now, that's just a wellbore this size now, in a mile in most cases. That'll hold a whole section of land. And the incentives Louisiana gave, it was even better. It didn't help our budget much, but a lot of wells drilled very quickly in the Haynesville. It started out in Texas in the Barnett, and very slowly in the 1990s. But 2007, beginning of 2008, is when we kicked off the largest shale development anywhere in the world. Was the Haynesville Shale. These wells are still the largest, up to 40 million cubic feet per day. I don't know of any other wells to produce that high stimulated wells. Just to show you some production over this time frame, 2007 and 8 is when we kicked in with fracking. We also started getting to tight oil. We don't want to call it shale oil. It's too confusing with the oil shales out west. So we call it shale gas, and we call it tight oil, are the two terms for your engineering students if you ever get involved in oil and gas companies. This is a fairly recent study done on the Haynesville over in East Texas, Panola County, Rusk, Gregg, Harrison. The red spots, of course, are what are left in the ground, we believe, and we believe there's up to 72 TCF of gas, trillion cubic feet of gas. I have not had a lot of field discoveries, but I did add somewhere between 1 and 2 TCF to Carthage Field with a lower zone that no one ever tried before. Now it's drilled all the way to 200 miles south, or 100 miles south of that area in Louisiana, everywhere, the zone that they go to in the Cotton Valley. I'm not going to go through the details here. It just shows you what we have left in the ground to work with, but about 72 TCF, there's a lot. Read this guy, Zihan. Read him. I don't care what field you're going into, read him. He was involved in the oil and gas industry, but he goes into the Middle East issues. He goes about transportation, economics, any field you want to go into. Read this guy. He knows what he's talking about. It's the end of the old world, trade. What trade? Look what we're doing now, USA, as far as our imports. Look how far we've drawn down with the shale. We are now the swing country in oil and gas, not Saudi Arabia. The U.S. is the swing country for oil and gas. That's only come out recently. And that's why they have been blowing it like crazy in Saudi Arabia. Blowing it to the point that we're in a crisis in the oil and gas industry here in Texas. Horrible crisis right now. We were too good, as usual. It worked too well. Again, some of the things that we work with is very technical and very interesting in oil and gas today. It uses every field. If you're a physics major, engineering major, you can learn the geology. There's still going to be great opportunities into the future. You don't change types of energy overnight. It takes at least 20 to 30 years for us to go to electricity, which is not a form of energy, by the way. It's a conveyance, okay? And mostly comes from coal, which is very dirty. Don't get me talking about that subject. We got to use it. We need to go there. I'm for it. I'm writing a paper right now on it. This is seismic showing fractures. This is how great a resolution we can see underground. Thousands of feet deep, 3D seismic. We actually see the fractures. I cored that deep sand for the first time in Carthage Field and found open fractures. Didn't realize what I discovered, but I discovered the play that would make us here in the United States. That sand is covered by shale on top and shale on bottom. We were fracking into the shale, getting our gas mainly from the shale, not the sand. But I cored it. So open fractures with crystals in it. The only way the crystals could form is if you had a fracture. It was not an induced fracture while you were drilling for your engineering majors. You will fracture the rock when you drill and core, but this was not induced. If you find crystals in the face of the fracture, it was there naturally. Just to show here in East Texas, in particular the Cotton Valley Lime, drilling horizontal has made all the difference in the world. Unfortunately, there's been a lot of geologists out of work that did nothing but sit at their home and do geosteering. They didn't learn any geology. Practically no geologist go out to a rig floor, see what a rig's like. It's just, I can't believe it. I gave a field trip we have a big society called the Gulf Coast Association of Geologic Societies. 2009, I had a huge bunch of people show up just to go out and see a rig. There are big rigs, top drive rigs, used offshore. Just to give you an idea, this is a lot of complexity. You've seen them all around you here with the fracking going on. I won't go into details of that, but it goes down thousands and thousands of feet below the surface of the earth. You'll frack it over several segments. You can see it in more of a 3D mansion now. Now what has happened is we've gone from this evolution of a 1-to-1, a vertical well, 10 feet of pay, to now going horizontal in one well, and then going horizontal in another zone. And then ultimately what we've done is this. We've gone to the ratio now, and we'll go through this kind of quickly. It adds up quickly to where we're at today. 23 miles of reservoir contact with the formation right there. 30 miles of lateral pipe attached with one straw at the surface. That's not much impact at the surface, is it? 30 miles of contact with a formation. Multiply that times 5,280. So the industry's got extremely efficient. Some of the issues about oil and gas on a regional basis I do go into worldwide. I'm not going to really get into it here, but Shell is huge worldwide. No one else has the infrastructure to do what we're doing yet. That's why we're the swing country. This is what's been happening with the oil. This is what we're doing now, is we're actually selling oil and gas, or compressed gas, from these massive fields like the Hanson in Texas and Louisiana. We're selling it off the coast of Texas and down at Sabine Pass in Louisiana. Are selling to other countries now. We're exporting here and on the West Coast. We're exporting for the first time. Had to change some laws to be able to do that. This gives you an idea of the Sabine Pass terminal. What ties, there's so much infrastructure built in World War II, mainly. It saved us from World War II. East Texas Field saved the United States. Simply put. It did help to have the Big Inch and Little Inch pipeline that took it to the industrial Northeast where everything was being built. Liquids and gas. A lot of gases in Louisiana. Certainly all was coming out of East Texas Field. If we hadn't had East Texas Field, we may have lost that, and probably would have lost that oil, in my opinion. Don't underestimate what these things have done for us. Refracking, they're just starting to do that. We've seen some effects of it. The most that they refract is in the Hanson, anywhere in the world, and seeing some great results. That means using some more water, about 6 million gallons per frac job. It's not a lot of water when you add it up. It's not continual use. You use it one time, maybe twice. It's not a continual use, so it doesn't affect your weather. So, resilience. This is what we work for. We've got to do things in a way that will be able to be able to project it into the future. I like this picture to show that. It's corporate and government resilience. A good movie's coming out, I think. Deepwater Horizon coming out. Have they seen that coming up? Everybody likes a star. Hopefully we'll make it. Well, this is the last slide we'll talk about. We have inherent resistance in our communities. We need to work and do those. We lost it during Macondo incident because the government came in and started throwing money around. And they stopped fishing and they started working for oil and gas companies. And that's the model I put together in 2001. It works today, local government, university, working with the community. And our last slide. Isn't that pretty? My assistant took that. I didn't take it. That's my floating dock. And by the way, that dock did not go under in the flood. Our building did not go under the flood. We're built inside the floodplain on stilts. That's what I have to give. Thank you very much. Thank you very much.
That was a dense talk. There was lots of stuff.
I know it's a lot of stuff.
One question from the audience before we close up? Yes.
So I've been reading some research about fracking possibly, or a specific type of fracking possibly being linked to earthquakes in an area. Can you
I spoke in
verify that?
Oklahoma twice before they finally agreed that in fact it was causing earthquakes up there, telling them it was happening. I worked at it at the national level. What's happening up there, they got this giant zone that goes for, I don't know, hundreds of miles. Each well brings out 1,000 barrels of water with their gas. 1,000 barrels of water with each well. So they have to put it back down. They take it to the Arbuckle, which is the deepest formation, and the crust of rock is right below it, and it causes earthquakes. I went to oil and gas twice in one summer up there to tell them, and no one disagreed with me. Yes?
Not the fracking.
Not the fracking, not the fracking. The injection of the water. Fracking does not cause any earthquakes. I mean, it's like .05 on the scale instead of a 4.5. And I've met with a person who's the top expert in the world on that and discussed this subject. Very good question. It is happening in many areas. We're able to pull back. There's one place in Texas called Timpson. You pull back. There's one place where it gets to the basement because the salt's not there. In fact, they were causing earthquakes. Minor earthquakes over at the Dallas-Fort Worth Airport. Everywhere else, there's really not earthquakes. I was in the North Ridge. That's an earthquake. 6.8 is an earthquake. When it knocks you on the deck and you can't get up, it's an earthquake.
Gary, I think it's important to compare, say, an earthquake, a result of disposal of water versus, say, a San Andreas or a large magnitude
Yes.
earthquake. You know, there's a difference.
These are minor. These are really, they're really not earthquakes. When you get up to a 6, that's 6.0 magnitude on the new scale we use. That can do some pretty significant. Now they're getting up, 5.8, 5.8. A couple of those is all they've had. These are minor quakes, are what they are mainly. This is not a huge problem by any means. In the areas where we've had it, they've been able to pull back on the amount of water they pump underground or the velocity they pump underground and totally stop it in Ohio, in Kentucky, in numerous areas that the press never brings up, especially 60 Minutes, the times I've worked with them on a couple of projects. But that's a very good question. It is caused by the injection of water, but they're minor quakes. They're not really what we see in California, like the 6.8 I was in. These are not devastating earthquakes, and I don't think ever will be.
All right, if you want to learn more about earthquakes, come and join us at the Corner Cafe in the Joyceville. Let's
Good
thank
question, Bob. Thank you. Great audience. Yeah. Great audience.